Okay, so today we are going to take the definitions that we learned yesterday and apply them to theorems. There is a direct correlation with what we did with congruency triangles, or congruent triangles I should say, versus similar triangles. So when we started congruent triangles, we said if these two triangles are congruent, or if we want to prove these triangles are congruent, we need to prove all 6 parts are congruent. So we needed all 3 sides, we needed all 3 angles. However, we quickly realized that that was too much work, so we came up with a bunch of shortcuts. And those shortcuts were?
Angle, side, angle.
Angle, side, angle is one of them.
Side, angle, side.
Side, angle, side.
Side, side, side.
Side, side, side.
Hypotenuse, side.
Hypotenuse, leg.
Angle, side, angle. Or
We did that one already.
Side, angle, side.
Angle, angle, side.
Side,
What
angle,
doesn't work?
Angle, side, side.
Angle, side, side, and?
Side,
And angle, angle, angle.
Side,
Yeah,
side.
side, side angle is just angle, side, side, if you don't have the guts to write ASS on your paper. Well, we're past that point, we're not afraid.
Are we gonna eventually have to do proofs with this?
Kind of, not, I know that's a weak answer, but it's not a similarity proofs are really hard to do in a traditional 2-column. You're just gonna be showing that they're similar. You'll see, we'll do one of those. Okay. So, here we go. We're gonna start with a problem, and the problem looks like this. This is you in your wagon of math books. And this is a flagpole. It's the only decent picture I could find of a flagpole, so just bear with me. You're 5 foot 6 inches tall. Now, for future reference, 5 foot 6 inches is not 5.6 feet. Okay, people do that all the time. 5'8" is not 5.8.
That's exactly how tall Johnny is.
Is that giant?
Do you have blue pants and a green shirt?
I could wear one, but
Do you have a wagon full of math books?
Hey, how do you know they're math books?
how do you
They could be library books.
Why wouldn't they be math books?
Well, it could be library books about math.
There's lots of different
What if he
books.
struggles in the subject?
They could be Kindles. They could be Kindles in those cases that look like books.
That's
true.
Or they could be those
Board
secret
games.
things where you carve out the rest of the pages and you put secret things that you secretly
Everyone does.
So you're suggesting they're regular library books and he's carved out to hide his math books inside.
No, he's not
No,
hiding
it's
that.
Yeah.
No, he's not
Oh,
hiding
I
it
feel like
there.
some people
So what's he
might
hiding in the
accidentally,
book?
They like cut out things out of the book.
I don't think so.
That's actually a thing though.
Look at his
People do that.
smile.
They
He
do,
looks
like,
like he's
they
hiding
do, like,
something.
accidentally.
That doesn't mean you're going to.
No.
We're going to operate under the premise that Johnny has math books with him in his wagon.
And what's going on with the flagpole?
He said it was the only picture of a flagpole he could find.
Oh.
Again, it was the best picture I could find. We know how tall Johnny is. We know how long his shadow is. Those are easily measurable things. We can easily measure the shadow of the flagpole. Just lay a ruler out on the ground and measure the shadow. What we can't easily measure, because we don't have the ability to run up the flagpole like that guy, is the height of the flagpole, so we can use math. How are we going to find the height of the flagpole? Go ahead.
Well, you do a proportion with like the 5, 6 over 6, 6, and then equal to the f over 125.
Can we use 5.5 instead?
Yeah.
Okay.
That's what
What did you call it? F?
yeah, that's fine.
Yeah, I got it. Okay, couple questions. These are in feet. This is in feet. We're fine. What if these were in inches?
Multiply by 12.
Then you would.
We'll come back to that question in a second.
Wait, not
Wait.
multiply by 12, divide by 12.
Oh,
Or you
yeah.
can multiply the other one by 12.
Yeah, you.
You can multiply whichever one is in feet by 12.
After that long diatribe, basically we need to convert to the same units.
Yes.
Okay, good. Did you have something to say?
No.
I thought maybe you had a joke to tell us.
Hey, yeah, Viraj, why
Yeah,
don't you
Viraj.
tell us a joke?
What do you got for us?
Okay, so what kind of jam can't you eat?
I don't know. What kind of jam can't you eat?
The traffic jam.
Ah!
really dumb. Okay, cross multiply, solve for f, please. Before you get done with that problem, is the flagpole going to be taller or shorter than 125 feet? Why?
Because the shadow's bigger than the actual.
Shadow's bigger than the actual thing, so that has to hold true between Johnny and his math books in the shadow and the flagpole in the shadow.
We're only doing 5.5 because it's like 5 to 6 inches.
Yeah, you can't really do the calculation with 5 foot 6 inches.
What would it be if it was like 5 to 5 inches?
Then it would be 5 and 5/12,
Oh, that's cool.
or you convert it all to inches. Okay, what do you got? Sorry, what? Wasn't that good that you wanted to repeat it?
It wasn't a joke, I said you could convert it to centimeters.
You could, yes. Or miles, light years, hands. Answer? Go.
I got a 105.7692308 feet.
That's what I got.
We could maybe round that.
Yeah.
Okay.
5.7.
105.77.
7,
8.
8. Oh, 7,
Good.
7.
Units?
Feet.
Feet, great. That calculation is based on one simple fact that we don't know. That calculation is based on the fact that those triangles are similar. Are those triangles similar?
Yes,
Why?
because the sun's in the same place.
So,
The light is shining from the same angle.
therefore,
They're similar.
and the hand flourishes help solidify that thing. They're similar. So just because the sun's in the same space, the same place, all triangles are similar then?
No. Well, the sun is shining on both of them.
So any triangles the sun shines on makes them similar? It's like magic. No?
No, I'm not.
What do you got?
Since the sun is shining in the same spot, the height of an object has the same ratio of the height to the length of the shadow. Right? No?
Wow, that sounded really intelligent. Why?
Because,
This is because I said so theorem.
yeah.
What do you got?
Well, all the angles would be congruent because since you're standing like upright and flagpole.
All right, so I'm assuming both your legs are the same length,
Yeah.
so you don't, Johnny?
Yeah.
Oh.
Okay, so you don't lean when you stand. So we're gonna stand, you're not doing that Michael Jackson, Eddie, are you okay lean?
Like Buffalo Grove.
That
expression.
Buffalo Grove expression.
I know, right?
I love inside jokes.
Wait.
All right, back to you. So there's one pair of angles.
Yeah. Okay. So, like we were saying, that since the light is shining from the same place, it would create like the same angle
Where?
on
Here
the,
or here?
on the ground.
Here?
Mm-hmm.
Okay, so that would be equal to that. And then why are these angles equal?
Because
No choice.
it's the last one.
No choice theorem, also known as the third angle theorem. That's great. That's one half of what we need to prove triangles are similar. We have the fact that the angles are congruent, but what about the sides? We can't use what we use to solve the problem to prove that they're similar because the similarity is required to solve the problem. What do you got?
Wait, could you explain why that third angle is?
If two pairs of angles and two triangles are congruent, then the third pair has to be congruent because they have to add up to 180 degrees.
Okay.
Okay? So this creates a problem. We can't stay with our initial definition of similarity to prove these two triangles are congruent. We have to come up with a different method, and so this is where our shortcuts come in. That is the correct answer. These triangles are similar, but we can't prove they're similar using what we've talked about over the last couple days. Leo?
Oh, no.
Okay. Chicken. 105.8 feet. Good. Oh, wait a second. We had another thing to discuss. I asked about converting units. So what did we figure, what are you, 66 inches?
Yeah.
So if I have 66 inches over 6'6", which is 78 inches, is this going to be a problem?
Yes.
All right. Cross multiply and solve.
Wait, like the right way or?
Solve that proportion.
Wait,
I would prefer that you solve it the right way, yes.
Nah.
2. That would be the wrong way. Uh-oh, what happens? It works. Even though these are in inches and this is in feet, it still works. So what if we go back to what the other thing you said? Well, no, you need to convert everything. Okay, so let's do this. What's 125 times 12?
1,500.
1,500 exactly. Okay, solve that. So this was, here we got F equals 105.88 feet. We'll call that F1. This will be F2. What's F2? George, you have an answer?
1,269.
1,269. So this method doesn't work?
No.
No. It does work.
Sure,
That would be the
divide it into
inches.
all
Divide that number by 12.
Oh, yeah. It works.
105.8. Okay, so that just makes it in inches. All of those methods work. You don't have to convert units. The only time you need to convert units is if your ratio is in different units. So if his height is given in inches and his shadow is given in feet, and the flagpole is given in inches, then you have to do some conversion. You want the ratios to be in the same units. So notice here we did inches on that ratio and feet on that ratio. It worked out okay. Inches on that ratio, inches on that ratio. It worked out okay. Just try not to mix units in the same ratio. Okay, moving on. So the first one we get is angle-angle similarity theorem, which is what we use to prove those triangles are congruent. We proved that at least two pairs, we actually proved all three pairs, and this used to be called the angle-angle-angle similarity theorem until somebody realized we don't need all three angles and just made it the angle-angle similarity theorem.
Who was it?
Bob Jenkins,
Oh, really?
the professor at Cambridge. Sorry, Dr. Bob Jenkins, professor at Cambridge. Well, Dr. Robert Jenkins. I know him as Bob.
I don't like the mistake.
No, they don't like when you call him by the wrong name or forget the doctor. Is anybody's parents a doctor?
I like.
Yeah.
Like in a doctorate or like actual helping people?
No.
Because he has a PhD.
Right. Okay, a PhD. It doesn't have to be an MD, it could be a PhD.
Yeah.
Dad or mom?
Dad.
Dad, does he shove the knock down everybody's throat?
No, he has a PhD in chemistry.
Okay.
He's not like an actual doctor where.
So like when you guys are waiting for a restaurant and they call your dad's name, he doesn't like get up in their grill and say, no, that's doctor.
He does like to be referred to as Dr. Roden.
Right, but not when he's waiting for a table at Chili's.
No.
Okay, there are some doctors like that. Yes, sir.
Yeah, I have, to go along with the Jewish stereotype, I have 3 uncle doctors on my Jewish side. They're like actual like doctors, like MD and stuff.
What is this? They listen to their headphones when they're doctor? Oh, is that supposed to be a stethoscope?
Yeah, I.
Oh,
like
okay.
that.
That's the international symbol for doctor.
And yeah, jokingly, shut it down.
I'm sorry, what?
Jokingly, they make you call it doctor.
Right, yeah, but they don't really.
No,
No,
no.
okay. Yes?
My mom knows a guy named Dr. Doctor.
Shut
No
His
way.
last name is
His
Doctor?
first name is Doctor.
No way.
Yeah, she's in charge of the Orthopedic Trauma Association, so there's all of these doctors, and like, they call our house, and they're like, this is Doctor.
That's so cool.
Not that I doubt you, but I do. Can you prove that?
I mean,
Call your mom.
We could search the association online.
Okay.
What's the
Or-
association?
The Orthopedic Trauma Association.
Yeah.
Your mom could confirm this, all right?
My mom's at work, and I'm not allowed to call her.
Can you text her?
Sure. Or for recording. Should I text her work phone or regular one?
Just ask her to confirm.
Okay.
But wait, hold on. You gotta send the text so that you're not telling her what to say. Just say, can you confirm the name of that doctor that's got the really weird name you told me about?
There's a few.
Oh, well, okay,
What's
maybe.
another one?
Just ask all of them.
Okay, 1 minute.
Next row.
Please send the list of all the doctors you know. All right, while you're doing that, I'm gonna continue, otherwise I'm gonna run out of time. Okay, so if you prove two of the angles congruent in the triangles, that's sufficient for those triangles to be similar. And once they're similar, we can go and do all these calculations that we did with the flagpole. Calculate the corresponding side lengths, setting up proportions, doing all that fun stuff. Okay, well, keep that with you so we know what happens when she replies.
Wait, so we don't even need to prove that the sides work?
Nope.
Just that's all.
No, just like when we did congruency, once you prove that all three pairs of sides are the same length, the triangles are congruent, and then we went on and did things like CP, CTC. So this is saying just prove two pairs of angles congruent. So if we go back to the picture here, once we knew that we had a right angle down in the corner and the sun created a similar angle in the other corner, we knew the triangles are similar, and that allowed us to do the calculation. Okay, there are a couple more. Side, side, side similarity. You remember that guy from yesterday? The tilde at the end of this theorem is very important. Without the tilde, it becomes side, side, side. And side, side, side is a congruency theorem. This is a similarity theorem.
Doesn't side not work in congruency then?
Side, side, side does work. It's angle, side, side that doesn't work. And like I said, we did this the other day. 6 over 2 is equal to 7.5 over 2.5 is equal to 12 over 4.
Angle doesn't work in congruency, right?
Angle, angle, angle is what we just did.
No, but in congruency.
In congruency, no.
Okay, that's the one.
And that's why when we kept talking about angle, angle, angle in congruency, I kept saying it doesn't work here, but it will work later, as opposed to angle, side, side, which never works. Okay?
No.
Okay.
Side, angle, side similarity?
So is it basically all the, like, past ones with addition of angle?
Well, kind of. We're going to drop, hypotenuse leg doesn't work for similarity. Well, it might, we're just not going to use it. And then the other one we don't talk about is angle, angle, side. So side, 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 angle, side, and AA. Remember when we dealt with side, angle, side, you've got that idea of the included angle being the angle between the two sides that we're talking about. So again, the angles have to be congruent, 67 to 67, and the sides have to be proportional. 12 is to 4 as 9 is to 3. Has a scale factor of 3 there. Or 1/3, depending on how you want to do it.
So the sides are never like necessarily congruent, they're just proportional.
Correct. If they are congruent, then the triangles would be congruent. And are congruent triangles similar?
Yeah. Yeah.
Yes.
Yes. Are similar triangles congruent?
No.
Not always. All right, so let's look at an example here. Are the two triangles similar?
that ever annoy you?
The mice.
It bothers me.
It's gotten to a point where I don't really hear it anymore
Don't look.
until somebody points it out, and now I'm gonna obsess on it the rest of the period. Thanks, Faith.
Alyssa, it's mice. Alyssa, it's mice. You
It
know
happens all the time. I was actually hoping, because over break they were supposed to change those to whiteboards, and then you wouldn't, you just through the wall.
So
Yes, Leo,
I,
please. Are they?
yes they are.
Why?
Because 15 is like well, triangle MNP is proportional to MRS because it's like a 3 to 2 or 2 to 3 scale factor. Because 10 over 15 is 2 to 3.
10 over 15 is equal to,
2/3.
it is equal to what other,
Oh, 12, 18.
12 to 18?
Yeah.
There's a problem there. What's wrong with that statement? Bert?
Well, because it's one big triangle, you have to include them both, so wouldn't it be 10 over 25?
Yeah, the 15 doesn't, the 15 isn't assigned to the triangle. We have to compare triangle to triangle. So it should be 10 over 25. That's the entire length of that side is equal to 12 over 30. It still works, yes. This is enough to show that those two pairs of sides are similar. That's not enough to prove that the triangles are similar. We need another chunk of information. Bill?
M is equivalent to M with a reflexive property.
Good, there's our second part, and therefore the triangles are similar by which theorem?
SAS.
SAS, similarity. Don't forget the tilde, it changes everything. The reason why this is so important is because now that I want to calculate NP, I have to use the right ratio. If I would have done 10 over 15, I'd get the wrong answer. What I want to use is 10 over 25 is equal to NP over 20. Question?
So would we have to write that angle M is congruent to angle M because of the reflexive property?
Just like congruency, you need to have these three chunks in there somewhere. These two chunks, the sides take care of themselves in one statement now, because you have those proportional. The other one you also have to have listed somewhere in there. The thing to remember about a picture like this, and you'll see a lot of pictures like this, is you have to compare triangle to triangle, not segments to segments. Okay, there is a theorem that we'll get to later that'll compare that side to that side, but we're not ready for it yet. And Caitlin has a response from her mom.
She said Dr. Bone, Dr. Hack, and Dr. Payne are some of the weirdest ones, but she didn't mention Dr. What should I say?
Dr. Bone, Dr. Hack, that's not a doctor you want to see, and Dr. what?
Payne.
Pain. Sounds like a villain in a Batman comic. Ask her, yeah, just ask her flat out about, can you confirm Dr.
Let's
Doctor?
be real here. Where was Dr. on?
I looked on the website, Dr. was not there, but maybe it's just he's not
No,
like.
I
I think she's
swear
calling
I
you
don't think
out.
you're lying.
I'll call her right now.
I don't think you're lying. I think maybe they're a different person in the association.
I know of a
Like
Dr.
another-
Tingle.
It's a weird one.
It's a weird one.
That's
My pediatrician has the same last name as me.
Yeah,
But
I know
not
she's
related.
my pediatrician. Well, she was.
Yeah, no, we moved.
Yeah. I didn't like her glasses. I did not like her glasses.
Perfect reason why I switched doctors.
Sure.
That's not why. It's just I didn't like her glasses. That's a part of why.
Yes, Leo.
NP equals bullshit.
Go ahead. 8?
yeah.
All right. Good. I like it.
All right, back to the doctors.
Don't call her. You said you weren't supposed to call her, right?
I'm not, but
You can
Here,
text
I'll
her.
call her. I will.
No, Leo. Because that'll get me in trouble. The hell are you doing in that math class? Your mom probably doesn't sound like that. I just,
answered.
she didn't
That's what all
answer.
moms sound like.
She's probably busy working.
No, her brother sees her on and said she read it and she just didn't pass it. Hate a woman
Wow.
with that.
Your mom's got to get smarter and turn that function off on the phone.
I turned it on for
turned-
her. She doesn't know what it is.
Great. That's awesome. Hold on, let me stop recording before we get